Okay, welcome to the last part of Chapter 2. This is 2.3 and 2.4, dealing with linear and nonlinear equations. Um, so I've got quite a few examples on how to approach solving equations. Okay, now for the here's how my rule of thumb is. Now, a lot of these equations, starting off, what we're going to do is you're going to see several or the same variable, but in different parts of the equation. So our objective is to line up all of the variables on one side and the numbers on the other. So if you look at the first one, what I always do is I look at the 3x and the 2x. And I look and see which one's greater. Well, the greatest one is 3x. So that means I need to move this x on the right side over. So since x is positive, we have to do the opposite. So instead of it being positive, think of being negative, or you need to subtract it. And if you subtract to one side, you have to do it to the other. So now this is 2x plus 7 equals 37. Okay, now we've went ahead and we put our x on the left side. So now we need to put the numbers on the other side. So now what we need to do is we need to right here, the 2, right here, we need to leave this just like it is, but we need to subtract 7 because you're adding 7, so you do the opposite to subtract. So you subtract 7 on both sides. I'll put it over here, so that's 2x equals 30. And then since that's 2 times x, you do the opposite and divide, and you come out to be x equals 15. Now, on this problem, I want to show you a quick method how to, especially since it's a whole number, you can always check your work. I'm going to put to check the work in this little box. So what I'm going to do is I'm going to rewrite the equation, except for the x, I'm going to put parentheses in, and I'm going to substitute that 15 in there. So then 3 times 15 is 45, plus 7 is 52. And then if you do 15 plus 37, you also get 52. And notice these two have to be equal. So that is, we did this correctly. If for some reason these do not equal, it might be something to do with whether you added or subtracted wrong, or maybe even divided wrong. Okay, let's look at the second equation. Now, throughout this lesson or in this video, please push pause and give you enough time to work it, and then come back and see my explanation. Okay, what about this next one? 7x plus 2 equals 10x minus 3. So my rule of thumb is I always like putting having the more positive x on the left side. So you can achieve this without messing up the problem by just rewriting 10x minus 3 equals 7x plus 2. It's the same equation, it's just you're flipping around the equal sign. So now I've got the 10x and 7x. So what I like to do is, like I said before, I take that 7, and since that 7 is positive, I'm going to subtract it on both sides. So I've got 3x minus 3 equals 2. Now, also looking at this, the reason why you don't need a plus 2, because 2 is assumed being positive, so I didn't need a sign there. So now I need to solve for this 3x right here. So I need to add 3 to both sides. And you get 3x equals 5. And then my last thing is, since it's 3 times x, you divide it. It's the opposite. So your answer is going to be a fraction in this point. It's going to be x equals 5/3. Now, just depending on what you're asked in your answer, they may say put it in a mixed number or a decimal, so just treat that how they want you to put it. Now, on this problem right here, this is the one that tends to stump everybody because in math, we like dealing with numbers, not a lot of letters. So what I like to do is this. I will look at what I'm trying to solve for. In this case, I'm trying to solve for B. So I'm going to circle the B, okay? And if you want to, you could go ahead and rewrite this as BC plus D equals A. And since I'm solving for B, that means I need to start getting rid of, I'm going to come back to this here in a second. I need to get rid of everything that's not associated with B. So when I look at this, I'm going to just circle BC because I'm protecting BC because B is what I'm trying to solve. So I want to get rid of this positive D or this plus D by subtracting it. Now I've got this BC equals A minus D. I cannot combine them because they're not like terms. Now by moving the D over, by subtracting it, that frees up the B and the C. Now I can get rid of that C. And by doing that, think about earlier in this example up here on number 2, when you had 3x right here, and it's 3 times x divided by 3, same thing here. It's BC. We're trying to solve for B, so I need to subtract, or need to divide C by the whole thing. So now my answer is going to be B equals A minus D over C. Or you could split up and say A over C minus D over C. Okay. Number 4, solving for n. So I noticed that right off the bat, I've got 2 n's. And luckily, they're on the same side. So what I want to go ahead and do is I want to go ahead and flip it and just say np plus nq minus r equals m. I need to solve for n, so I'm not going to do anything with the np plus nq. But what I'm going to do with that minus r is I'm going to add r to both sides. So that gives me np plus nq equals m plus r. Now, what do you do with the np and nq? Well, since they have n in common and I've got them on the same side, what I'm going to do is I'm going to take the n out. This is factoring the n out. And what you're left with is p for this, the np, your symbol plus, and since I'm taking the n from the q, that leaves me q. And finally, to end this problem, if I want to solve for n, I need to get rid of p plus q. And remember, you're taking this n and multiplying it. So by doing that, you're going to divide. So your final answer will be n equals m plus r over p plus q. Now this is going to lead up to starting to solve some things here in a little bit. I'm going to show you on your TI-83 or 84 calculator. But first, let's just take this example. This is a really simple example. I just need to find what x is. So since I just have 5x and that's greater than the 3x, I'm going to subtract 3x. And I get 2x equals 6. And just like before, you take your 2 and divide it because you're multiplying it, so you do the opposite. You have x equals 3. Okay? Now to check your work, which I would advise us to do on these problems that you get a numerical answer, is I want to say 5. I'm going to put parentheses in for x equals 3, parentheses in for x, plus 6. And then I'm going to put that 3 in for where x goes. So 5 times 3 is 15. 3 times 3 is 9, but 9 plus 6 gives you 15. That is a true statement. And that leads me to this crossing graphs method. So you're going to see this. You're going to see this on homework. You're going to see this on an exam, the crossing graph. Now, this is where your TI-83 and 84 comes into play. Now, what I want to do is I'm going to show you that I'm going to put the left side, I'm going to say it's y1, the right side y2. So that means y1 equals 5x, and y2 equals 3x plus 6. Now, on your calculator, if you look at the very top, so this is, I'm going to put little directions here for your calculator. At the very top of your screen, you'll see a y equals, okay? When you hit y equals, you just type in for y1 the 5x, and then hit enter, and then for the y2 you put in 3x plus 6. Your second thing you want to do is you want to find your second button, which is still at your right below the y equals. It's a colored one. Usually it's either blue or orange or yellow. And what you want to do is you want to hit second and trace. And the trace button is on the top right by the graph. At the top right, you hit that, and what it is, it gives you to calculate. Okay, so I'm going to give you some time to do this. And like I said before, if you you could pause this, go back and rewatch this. I know this is new to most of us. So then what you need to do after you do second and trace, look for option number 5. So you scroll down, it's going to give you some options, and you'll see the word intersect. So when you hit second and trace, number 5, it's right below maximum. And then you're going to see it'll start saying first curve, you hit enter once, second curve, enter guess. and it gives you, it's called the intersection. So the final step is going to be, once you hit enter, going through first curve, second curve, and guess, it comes up with intersection. So in our example, what you should get is x equals 3, y equals 15. That is where both of these lines meet, both of these equations. Now, if I scroll back up to here, when we checked our work from number 5, take a look at this right here. My x was 3. My answer that I checked was 15. That's your y value. So we did this by hand, and I'm showing you how to do this by calculator. Okay, I've got 2 more examples I'm going to show you with this crossing graph. Now, what I want you to do is, on these next 2 examples, I want you to follow my instructions 1, 2, 3, and 4. Hit pause, see if you can do it, and then come back and see what I have. Okay, so I've got this 13x minus 4 equals x squared. So what I'm going to do is I'm going to label, and I like using different colors just to show that your y values are different. 3x minus 4, and then y2 equals x squared. Now, we could graph this if you wanted to by hand, but our calculator does the work for us. So if I want to kind of scroll back up here so I don't have to rewrite this. So if you put in your, if you go back and on the previous example where we put our y1 and y2 in our y equals, you can always clear it. The clear is right below the arrows on the right side. And you can always re-enter the new y1 and y2. So after you do y1 and y2, and then hit second and trace, option number 5 that says intersect, and you go through and hit enter from the first curve, enter second curve, enter guess, and then your intersection point, you should get something like, it's going to be small, and they can be small, they can be big, or they can be small. So they should meet at 0.1 or 315 and 0.099. That's really small. Now, just depending on what they're asked, they may say rounded to the third decimal or rounded to the hundredth position. So do specifically what they ask you to round your answers to. Now, finally, in example 8, I've got x plus 7 raised to the x power. So y1 is going to be x plus 7 raised to the x. And my y2 is going to be 4. So if you go through and you do back to your y equals on your first step, and just clear out your y1 and y2 from your other example, and then put in x plus 7 to the x for y1 and put 4 for y2. And then after you do that, you go to second and trace. Option number 5, which is the intersect. And what you should come up with is x equals 0.625. And your y, watch this, look what your y equals, 4. Anytime on the equation, if you set it equal to a number, your y value is going to be that number. In this case, it's 4. Now, before I move on, I want to show you one little tip on your calculator, because when you do some of your calculations, and when your X and your Y value are huge, I mean, when you're talking about hundreds or thousands, what you need to do is you need to go to, on the top of your calculator, to window. You just hit window by itself. And what you're going to do is you're going to get a lot of different values. So I'm focused on X min, X max, and then Y min and Y max. Okay, what this is telling you is this. And I've got a little demonstration here on the left. What your calculator defaults to is that X minimum is -10, X max is a +10, Y minimum is -10, Y max is a +10. But when you get larger equations where they intersect, then your calculator is going to get errors. If you have errors, go to this window. So this is calculator, this is under the window, like I said before, and change it. It does not affect anything. So you may want it to just default them all as maybe -1000, +1000, -1000, and +1000, and just work your way. That just shows you when your computer kind of does a snapshot of where the intersection point is. The greater the values, you need to use greater numbers for your min, max on both your X and your Y. I hope that explains it. Like I said before, go over this video as many times as you need. And your homework assignment for this class, for our Math 150 class, will be on WebAssign homework number 5. Thank you for listening.